We're looking to find the length of the curve f of x is equal to natural log cosine of x on the interval between 0 and pi over 3. So as we start, the first thing we need to know is what is the equation we're going to be working with. So that is going to be our length equation. And this time we are going to be working with 1 plus f prime of x quantity squared dx. Now, I'm saying this time we're going to work with this particular equation because sometimes you may see this written differently depending on what reference you're using or what you may need for the problem. So sometimes it looks different, same thing. All right, notice what we have in here in particular is we have this f prime of x, so we're going to need that with our particular function. We started off with the function natural log of cosine of x. So when we take our derivative of f of x, this is going to be 1 over cosine of x times the derivative of the inside because we need to use our chain rule. So the derivative of the inside is negative sine of x. So this is going to be negative sine of x divided by cosine of x. In other words, negative tangent of x. So there's our derivative that we're going to be using here, f prime of x, and we're going to be squaring that. Let's pop that into our length equation. So we have L is the integral of 1 plus f prime of x quantity squared. We are taking the square root of that, dx on the backside. Our bounds here, we want this between 0 and pi over 3. Our derivative is negative tangent of x. We are squaring that. We are taking the square root of the whole thing. And then we are dxing it on the back side. Now, of course, you'll notice with the negative sign out front, the fact that we're squaring it is going to kill that. So we are going to end up with the integral of 1 plus tangent squared of x, quantity square root, dx. And as you may not know, one of our nice equations, actually let me put this in purple here. One of our nice equations, 1 plus tangent squared of x is equal to secant squared of x. One of those ones that's really good to know, handy in Calc 2, not so much in Calc 1. All right, so this is going to give us secant of x dx, and let me just keep our bounds up. We want to make sure we don't lose those at any point. So we're still going from 1 to pi over 3. The antiderivative of secant is going to be the natural log absolute value, secant x plus tangent of x. And we are evaluating from 0 to pi over 3. Punching in those numbers, so we are going to have natural log of secant pi over 3 plus tangent of pi over 3. And then we are minusing the natural log of secant of 0 minus or plus tangent of 0. All right, as we go through this, secant of pi over 3 is going to be 2. Tangent of pi over 3 is going to be root 3. Secant of 0 is 1. Tangent of 0 is 0. So that means that when we punch that in, we are going to get natural log of 2 plus square root of 3 minus natural log of 1 plus 0, which is 0. Natural log of 1 is 0 itself. So our solution is natural log of 2 plus square root of 3. And there is our solution. Thank you for listening.